Hello students, today we'll start with the chapter Work, Energy and Power, a second chapter of physics. Now, what do you mean by work? As for physics, whenever you apply a force on an object and the object moves or displaces in the direction of force, then work is said to be done. That means, students, you just understand one thing. You are applying a force and that force displaces the object in the direction of the force. Work is said to be done. Now, in case if you go to see, currently I am teaching you a physics. Now, if I ask you, am I doing any work? So yes, mentally I am doing work, but as for physics, I am not displacing anything, hence work is not said to be done as per the physics. And similarly, if I ask my students what they are doing, so obviously my students are also paying attention, they are also doing mentally work, but they are not displacing anything. That means as per physics, work is not said to be done. So in a simple thing, if I ask you to explain work, you can just say, when the applied force displaces the object in the direction of the force, work is said to be done. One more example, students, if I ask you to push the wall, so obviously while pushing the wall, you will definitely apply a certain force, but the applied force will not be able to displace the object or displace the, here the object is wall, so you will not be able to displace the wall. Hence, you are applying the force, but displacement is not there, hence work is not said to be done. So in a simple case, if I ask you, when work is said to be done? When the work is said to be done, when the applied force displaces the object in the direction of the force. That means, whenever we are considering work, the two factors on which work depends on are the force, that means the magnitude, the strength of the force, and second is the displacement. So obviously, yes, more the force, more is the work done, and more the displacement, more is the work done. That means in either case, the work is directly proportional to the force and the displacement. More the force, more is the work done, and more the displacement, more is the work done. And hence, we can say that work is a product of force and displacement. So, as of now, we have finished that what do you mean by work and the factors on which the work depends upon. Now we'll look about the physical quantities of force, displacement and vector. What are physical quantities, students? It means it is a scalar quantity or it's a vector quantity. Now if we go to see force, force is a vector quantity because whenever I apply the force, I have to see the direction in which I am applying the force. And second is the displacement. The displacement also is your vector quantity, because this is nothing but the distance in a specified direction. So both of them are vector quantity. So what can you say about the work? Work is not a vector quantity, it is a scalar quantity. The reason is because when I will ask you to do the work, the direction will not be required, you just have to complete a certain work. So whenever you will be doing the work, while doing the work, the direction will not play a role and hence it is said to be a scalar quantity. Now, what is the SI unit of work? Over here, if you go to see, the SI unit for force is Newton, the SI unit for displacement is meter, but the SI unit for work is not Newton meter, it is joule. The SI unit for work is joule and not Newton meter. Similarly, what is the CGS unit of work? Is erg. For force it's dyne, and for meter is centimeter. Hence, these are the SI and the CGS unit for the. So till now we have learned that work means the applied force can displace the object in direction of the force, and work is nothing but force into displacement, and this formula I can use when the displacement is the direction of the force. That means the formula work equals to F into S I can use when the displacement is in the direction of force. Now students, over here we have learned that whenever the displacement is in the direction of force, the work is the product of force and displacement. Now let us say, in case if you want to find the work where the displacement is not in the direction of force. Now tell me, in this case, can we say the work is done or work is not done? So it depends. As per the definition, we have learned that work is said to be done when the applied force displaces the object in direction of force. That is why we use the formula work equals to F into S. Now we are considering for the work if the displacement is not in direction of force. For this, I'll just give an example, students. In case if you want to displace a heavy object. Now what happens, whenever you apply the force to displace a heavy object, you will observe that applying the force at a convenient point, it will displace the body in the desired direction. Now understand, students, what is desired direction? It means that in case if I have a heavy object and I know that I want to displace this body at this particular part, that means now here I know that when I apply the force at this point, the body, instead of going in this direction, it moves in this direction. That means here the applied force is not displacing the object in the direction of force, but it is displacing in the desired direction. That means I wanted to displace this object in this direction only, and I could displace the object in the desired direction. But the applied force is not displacing over here in the direction of force. That means, can I say that work is done or not? Yes, my work is done. But can I use this formula? No, you cannot use this formula, because this formula is only when the applied force displaces the object in the direction of force. So now in this case, when the applied force displaces the object in a desired direction, but not in the direction of force, how will you find the work? So for this, we will just see the way how can you find the work done when the displacement is not in the direction of the force. So you can see, students, over here that the applied force has not displaced the object in the direction of force, but has displaced the object in a desired direction. So yet, even if applied force does not displace the object in the direction of force, my object yet reaches to a desired location. That means here you can see that this is the direction of the force, and this is the actual displacement, which is not in the direction of force, makes a certain angle. That means here the applied force will make a certain angle with the displacement. So here now we'll just understand the example. If I apply the force and the applied force displaces the object in this direction, that means my force over here is F and it has displaced the object by direction AB. So over here you can just see that the force over here, if I produce, this is nothing but the displacement. I want the displacement in the direction of force, or this is say the direction of the force. With this I can say direction of force or displacement in the direction of the force. So here, if I draw a perpendicular, I can see that there is a formation of a triangle. Here we will be using one concept of math, that is We have a different ratios, sine, cos, tan, cot. We don't have to use all the ratios over here, but definitely while selecting the ratio, we should know that which two sides you are considering. So over here, students, we know the force, we know the displacement also, but the displacement is not in direction of force, hence I cannot use this formula. So over here, if I want to use this formula, the displacement has to be in the direction of the force. That means in case if I have displacement as per AC, I can definitely use in this formula. So now here, I have to consider two sides with respect to the angle which is said to be your theta. Here, this is opposite direction of force and this is the displacement, it's making a certain angle. So over here, I have to consider two elements of this triangle, AC and AB. Why? Because AB is the actual displacement which has taken because of this force applied, and I want AC as a displacement which is in the direction of the force. That means to use this formula, I have to find AC which has to be in the direction of which will be in the direction of the force. So now over here, if I go to see, with respect to this theta, this is a perpendicular. With respect to this theta, this is hypotenuse. And this is your adjacent side. So students, in trigonometry, which ratio has adjacent and hypotenuse side available? So the answer is cos theta is nothing but adjacent side upon the hypotenuse side. So now over here, if I consider this, my adjacent side is AC and my hypotenuse side is AB. So AC, which is nothing but the displacement in the direction of force, will be available. That is, AC is nothing but AB cos theta. Now students, what is AB? AB is my actual displacement, that is S cos theta. Now I know that the displacement AC, which is the direction of force, is available. So now using this formula, work is F into S. F will remain as it is, and displacement in the direction of force is AC. And the value for AC is nothing but F S cos theta, because AC is nothing but S cos theta. Hence, here the work done is F S cos theta. That means here this formula you can use when the applied force does not displace the object in direction of force, but has displaced in some other direction, and hence you can find the work using Fs cos theta. Now we'll consider different cases with respect to what your theta. So now students, we have done that you can find the work also as Fs cos theta. Work is equal to Fs cos theta. In case now over here, we'll consider the different cases of this theta. Theta as 0, theta as 90, and the angle as 180. I'll explain you obviously each thing in detail over here. But you should know the value for the cos, because it's cos theta. So I'll just use certain value for the cos. Cos 0, 30, 45, 60 and 90. Cos 0 is 1. Cos 30 is root 3.2. This is 1 by root 2. This is half. And this is 0. So now over here, and also we have 180, which is negative. So now here, if I consider the first case theta as 0, the applied force, if it displaces the object in the direction of the force, that means over here the applied force is displacing the object in the direction of force, hence the angle between the force and displacement is 0 because they are overlapping each other. So when they overlap each other, there is no angle formed between the force and the displacement, hence the theta over here is 0. So now in case if we consider formula Fs cos theta, you will say, so if the applied force displaces the body in direction of force, so we can use directly work because F into S. Yes, we can. That is what we are deriving over here. So now Fs cos 0, because the theta is 0. Now what is cos 0? The value for cos 0 is 1. Hence, the work is Fs, which is the same thing what we have done in the first part, where the applied force displaces the object in the direction of force. Where the applied force displaces the object in the direction of the force, and such work is said to be your positive work. So, students, whenever you are applying the force, and the applied force displaces the object in the direction of the force, it is said to be your positive work. Similarly now, if your theta is 90, that means the angle between the force and the displacement is 90, then what will the work done? Fs cos theta, Fs cos 90. Now students, what is cos 90? Cos 90 is 0. Hence, the work done is 0. I'll give you some example to explain this. That means, understand one point, that when the applied force is perpendicular to displacement, the work done is said to be 0. In case the coolie has a load on his head. So now can you say that what is the displacement of this load with respect to force of gravity? So obviously when the coolie has a load on his head, the displacement with respect to force of gravity is perpendicular. Hence, no work is said to be done with respect to a force of gravity on the load which is there on the head of the coolie. The object is going in a circular path. The displacement is known by drawing a tangent. And as it goes in the circular path, the centripetal force which is acting on the object is perpendicular to the displacement. That means whenever anything which goes a circular path, like the moon revolving around the earth revolving around the sun, all of them go in a circular path, and hence the earth gravity over here is a force, displacement is what? The displacement of the moon, but the work done by the moon in revolving around the earth is 0, as the force and the displacement are perpendicular to each other. Similarly, in case if I consider sun also, here also the work done is said to be 0. That means, in other words, whenever you apply the force and the displacement is perpendicular to it, hence no work is said to be done. So I repeat, whenever you apply the force which displaces the body in a direction perpendicular to it, no work is said to be done. Similarly now, the last, first case, second case, and now the third case where theta is 180. That means you are applying the force over here, but the displacement goes in opposite direction. Work is said to be your negative work. So you apply the force in one direction and the displacement takes in the opposite direction, is said to be your negative work. Example, when you slide the book over the rough surface, the rough surface also exerts a force in a direction opposite to the motion of the object. That is nothing but what? A negative, because force in the forward direction, but the friction is applying a force in the opposite direction. Hence, it is said to be a negative work. Similarly, when you throw the object goes in the upward direction, whereas the force of gravity always acts downward. That means the object is going against the force of gravity. Again, the work is said to be your negative work. So over here, we'll just have a brief. When the theta is 0, it is said to be a positive work because the applied force displaces the object in direction of the force. When the theta is 90, the angle of the force and displacement is 90, and in this case, no work is said to be done, hence 0 work. And the last is that when the theta is 180, when the applied force displaces the object in the opposite direction, example is the friction force or the force of gravity when the object is going in the upward motion. So these are the three cases where we use work as Fs cos theta, and you can get a positive work, 0 work and negative work. Now students, as I have told you over here, 0 work. Is there any other case where you can say that no work is said to be done, or what are the conditions where you can say the work done is 0? The first case is when you apply the force and the applied force cannot produce any displacement. So obviously, if the applied force cannot produce any displacement, you can say work is F into S, displacement is 0, hence anything with 0 is 0, so work done is 0. So when the applied force cannot produce any displacement, work is 0. And the second case is when the applied force is normal to the displacement, or in other words, when the applied force is perpendicular to displacement, in that case also the work done is said to be 0. That means there are two cases where you can say that the work done is said to be 0. The first case is when the applied force cannot produce any displacement, and second case is when the applied force produces displacement which is perpendicular to the applied force, and in that case also work done is said to be 0. Work done by the force of gravity. Now students, over here, in case of, let us say, if any object comes downward, why this object is coming downward? Because the force of gravity is attracting it. That means the force of gravity always acts in a downward direction, and which forces the object to go in a downward direction. So here, what is the work done by the force of gravity? Obviously the work is F into S, as the object is going in the same direction where the force is applying. The force of gravity acts in a downward direction, and the object is also displacing in a downward direction, hence work is F into S. Now what is the force over here? The force is nothing but the weight of the body, and displacement is nothing but the height attained by the body. So here the force is the weight of the body and displacement is the height traveled by the body. So now here, if you go to see, the weight of the body is mass into gravity. The displacement over here is the height traveled by the body. Now over here, in case the body comes down by three different ways. Let us say by stairs, by a slope, or by an elevator. The same object or a person, if it comes down from the same height using a staircase, slope, or an elevator, tell me where the work done will be more with respect to force of gravity. I repeat, you have to tell me where the work done will be more, which is with respect to force of gravity. So here we are finding the work done by the force of gravity. So now students, over here, while considering the work done by the force of gravity, what we have to consider is the mass, gravity, and the height from where it is coming. So now tell me, as I have told you, the object what we are considering over here is same. That means the weight of the object will always be same, either the staircase or slope or elevator. The weight of the object is same. Second thing, the height through which it is coming also is same. That means weight and height in any case, whether it's staircase, slope or elevator, it is same, and hence the force of gravity will be same throughout, no matter through which a person is traveling, whether it is staircase, slope or an elevator. As the height is same, the person is same, and therefore the work done by the force of gravity also will be same. So this is the work done by the force of gravity. So always remember students, whenever the force of gravity is doing any work, it will always consider the weight of the body and the height through which it is coming. As they both are same, then it doesn't matter through what way it is coming, staircase, slope or elevator. Or if because here the staircase, slope, elevator does not play a role. What plays a role is the weight and the height, and they are same in either of the cases. Hence the work done by the force of gravity will be same whether it is staircase, slope or an elevator. Now students, lastly with respect to work, we will discuss about its unit. We have already discussed the SI unit for the work is joule and the CGS unit is erg. Now we all know that work is F into S. Now tell me one thing, when I am considering the SI unit for the SI for the work is joule, for the force is Newton, and for the displacement is meter. Why I have done 1? Because now I'll ask you, define 1 joule. Very, very simple students. Work said to be done is 1 joule when the applied force of 1 Newton displaces the body by 1 meter in the direction of the force, the work said to be done is 1 joule. It's so simple. Work done is said to be 1 joule. When the applied force of 1 Newton displaces the body by 1 meter in the direction of the force, work said to be done is 1 joule. Similarly, when the work is said to be 1 erg, when the applied force of 1 dyne, because the CGS unit of force is dyne, and the CGS unit of displacement is centimeter, and the CGS unit of work is erg. The work is said to be 1 erg when the applied force of 1 dyne displaces the object by 1 centimeter in the direction of the force. And this is how you define the work as 1 joule and 1 erg. With this, we have finished a sub part of the first exercise, that is work. The topic is power. What do you mean by power? Power means rate at which the work is done is said to be your power. Students, rate means what, you know? Time taken to complete a certain work is said to be your power. That means power is work upon time. The unit for work is joule. The unit for time is seconds. That means the SI unit for power is either joule per second, or also you can write as watt. The SI unit for power is watt or joules per second. When the power is said to be 1 watt, the power is said to be 1 watt when the work of 1 joule is done in 1 second. That means in case if you can complete the work of 1 joule in 1 second, the power is said to be 1 watt. If the work of 1 joule is done in 1 second, the power is said to be 1 watt. The bigger units are kilowatt, megawatt and gigawatt, which is nothing but 10 raised to 3 power. 1 kilowatt is 10 raised to 3. 1 kilowatt is 10 raised to 3 watt, that is 1000 watt. Mega is 10 raised to 6 and giga is 10 raised to 9. And similarly we have a smaller unit also, that is milli and micro. 1 milliwatt is equal to 10 raised to minus 3 watt, and similarly 1 micro is 10 raised to minus 6 watt. And the other unit for power is very important, horsepower. 1 horsepower, which is known as 1 HP, is 746 watt. This is normally we use where the power required is more. Example, car. There the power will always be denoted as what? HP, which is equal to 1 horsepower is equal to 746 watt. So this was all about the power. Now how will you distinguish power and the work? Whenever you are differentiating anything, the first point will always be the definition. So power definition is the rate at which the work is done, and work is when the applied force displaces the object in the direction of the force. Second, the SI unit of power is watt, and the SI unit for the work is joule. First point, you write the definition. Second point, the SI unit of the power is watt, and SI unit for the work is joule. And the third point, in power, we consider the time taken, and in work, time is not considered. So this is how you can distinguish between the power and work. The first point is definition. Second point is the SI unit, and third is your time is definitely taken into consideration. Your time is not taken into consideration. So this is all about your power. Now we'll start with the next topic, energy. Now the last part, energy. Energy means capacity to do work. That means obviously work means the displacement in the direction of the force. So to complete that displacement you require certain force, for which you require what? Energy. So energy is nothing but the capacity to do work. Energy is capacity to do work, and that is why the unit for work and energy are exactly same. That is, the SI unit for the work and the energy is joule, and the CGS unit is erg. Why? Because your work completely depends upon the energy. Hence, the unit also is exactly same. The other unit for the energy are watt hour, kilowatt hour, calorie, and electron volt. Now, what do you mean by watt hour? Watt basically, obviously, when the word watt comes, it means power, and this means time. This is nothing but the watt and the kilowatt are nothing but the commercial unit of electricity. Now, how will you explain watt hour? Watt hour means if an appliance has a power of 1 watt and which is used for 1 hour, then the energy spent in doing the work is 1 watt hour. So 1 watt hour is what? If an appliance has a power of 1 watt which is used for 1 hour, then the energy spent in doing the work is 1 watt hour. Similarly, 1 kilowatt hour of 1 kilowatt used for 1 hour, then the energy spent in doing the work is said to be 1 kilowatt hour. Calorie. Calorie basically is always in terms of heat. It is nothing but something with respect to heat energy. One more thing, students, calorie is always and always with respect to water. With respect to water. So now what is 1 calorie? 1 calorie is the amount of heat energy required by 1 gram of water amount of energy required by a mass of 1 gram of water to increase its temperature by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius. What do you mean by this statement? And why you have to write this? Obviously this is 1 degree, but particularly why after this particular temperature only? The reason is because water normally has anomalous behavior water. The strong behavior of anomalous behavior water is found between 0 to 0.420. But the traces of this behavior are same till 14 degrees Celsius. Hence, the water starts flowing smoothly only after 14 degrees Celsius. So for that consideration, we take 14.5 to 15.5. The amount of heat required by a mass of 1 gram of water to increase its temperature 1 degree Celsius from 14.5 to 15.5 degrees Celsius is said to be 1 calorie. What is electron volt? Electron volt is basically a very small energy. It represents a very small energy which is basically required by the atomic particles, and it is defined as electron volt is the energy gained by an electron. It's the energy gained by an electron when it is accelerated. Accelerated means what? Change in velocity. When it is accelerated by a potential difference of 1 volt. So defined electron volt is the energy gained by electron when it is accelerated by a potential difference of 1 volt. Now distinguish between, similarly, how we distinguish between work and the power? Same way we distinguish between power and energy. The first point, as I've told you, will be definition in each case. Second, the SI unit for the power is watt, and the SI unit for the energy is joule. Your time is taken into consideration, and here time, first point, second point, and third point. Time is not considered. Over here, students, one more point. 1 electron volt is equals to 1.6 into 10 raised to minus 19 joule. So this is just a value for 1 electron volt energy, which equals to 1.6 into 10 raised to minus 19 joule. With this, we have finished exercise A of work, energy, and power.